Hello, everyone. So, we have been discussing all different components of thermochemistry, and tomorrow on Thursday, we are going to conduct a lab that just brings everything together that you all have learned and discovered up until now over chemical enthalpy. So, we're going to be discussing the different components that you're going to be looking for in the lab and experimenting with, and then in the end, calculating. So this lab brings in the two processes that we discussed with endo and exothermic. So just kind of as a review, endothermic, these processes absorb energy. So their delta H, or the enthalpy change, we learned that delta H is enthalpy, is positive. So kind of remember back to when you get your paycheck or you get money for your birthday, you receiving that money, you become positive because, hey, we've got money. And so the same concept for endothermic, the substance is absorbing energy from the surroundings. So the system is absorbing the energy. So it becomes positive. It gains something. It gains that energy or that heat. And then our exothermic processes, these release energy. We go from the system releasing out into the surroundings. So our delta H, our enthalpy, is negative. So again, with the receiving money, you go out and you start buying things. Well, now you have less money than what you originally started with. And so the same concept with the system releasing its energy from what it's absorbed initially, and it's going out into the surroundings. So our delta H is now negative. So these two processes you're going to be able to observe directly in the lab and determine which chemical, we're going to be using two chemicals, is going through an endothermic or an exothermic process. And then enthalpy, so we will be using our enthalpy equation. So just as a reminder, it's delta H equals M times C times delta T. And our M is our mass. You'll have a specific mass of water as well as the two chemicals. Then the specific heat of each chemical. And just as a reminder, the specific heat is the amount of heat that's required to raise that substance's temperature by 1 degree at 1 mole of it. So remember, each substance that we have here on Earth has a different specific heat. It takes a different amount of energy to heat two different substances up to the same temperature. And then our delta T is change in temperature. Now remember, this is usually given to us as a range. So it's not the initial temperature that you start with, and it's not the final temperature that you end up with. That delta, you've got to find the change in it. So if we were to start with 30 degrees Celsius and our temperature went up to 45 degrees, our delta T is not going to be just 45 or 30. It's going to be that 15 degrees. It's going to be the difference between the two. And so you're definitely going to be on the lookout for that during the lab, because that's going to be a key component in helping decide if it's an endo or exothermic process. So just be sure that you have this equation written down, that you know which each variable is, to be able to help you throughout the lab. So now to discuss the lab, you're going to be given two chemicals and you're going to be calculating the enthalpy, the differences in enthalpy for these two. And I'm not going to tell you which two, because you're going to see and kind of make a hypothesis of which one you might think would be endo or exo, or which one's going to have the greatest enthalpy difference. And so the way the setup is to get you started, and that way you can get in the lab and get going, so you have time to do the calculations at the end and ask questions. You're going to be giving a whole styrofoam cup that's going to be inside of a koozie. So this is going to be your insulator. This is what you're going to put the water and the chemical in. Then you're going to have a styrofoam cup that is cut in half and has a hole in the bottom of it. Once you have gotten your two components that you need inside of the regular cup, you're going to place the half styrofoam cup inside the top to create like a seal. There doesn't need to be any open space except for the hole that's in the top. So then you're going to have a thermometer. It's just a normal thermometer with a reading. And you're going to place the thermometer inside of the hole in the top of the cup until it just barely touches the bottom. If it's barely touching or just a little above, so that way you get a proper reading. And you'll need to record that initial temperature, and then you're going to be able to swirl the cup around to allow the reaction to occur a little faster. And then you're going to get a second reading. Either it might go up, it might go down, and so you just need to be sure that you record both of those readings from your thermometer. There will be scales out around the lab because you're going to need to measure out the appropriate gram amount for the chemical as well as for your water. So just be sure that you've zeroed everything out and you're getting your proper reading of weight for both the chemical and the water. So you'll have 3 different readings total. And then you'll need a timer. I'm fine with you using your phone just for that, just to have a proper reading of the reaction time, and you're keeping the experiment consistent throughout. So that's just kind of the setup of the lab so you can get in there and get going when you turn your paper into me. So just some tips. Be sure to be consistent with time and swirls. You need to make, you and your partners, you're going to be in groups, either with a partner, but no more than 3 people. So be consistent with the time. You set a time, either a minute or a minute 30, to test both chemicals for both experiments and to keep consistency, as well as swirls. You don't want someone just shaking the cup back and forth, and you don't want someone going in a circular pattern. You need to set how you want to do it, and the lab instructions will tell you the best way to go about that. But just be sure to be consistent with both of those. And then the last thing, when you're doing your calculations, remember the correct signs for either endo or exothermic reactions. You've got to be sure that once you've calculated out everything, that you have the proper sign for it, because that's going to show me that you understand what signs defines which reaction, as well as you get the proper calculations for it overall. So just be sure that you and your partners turn in your notes to me. I will be looking to make sure that you've completed these, because if someone in your group hasn't completed this portion of the lab, they will have to do that before they can actually get into the lab. So I suggest that whoever your partners are, you 3 make sure that everyone is watching this and taking notes over it, so that way you all can get into the lab at the exact same time. So this is going to be a fun lab. It can seem a little short, but you're really going to get to see how enthalpy is observed, as well as an endo or exothermic reaction in the lab setting, rather than just calculating it on paper. So it's going to be a lot of fun, and I will see you in class.